All right. So I've got a few questions. I'm going to go ahead and go through them. And I'm going to just sort of hit on them one at a time as I see them. A couple of questions, I'm going to do them a bit out of order. The first is how much will we have to know about individual, or how much will we need to know about Java streams in terms of individual methods? That is on the study guide. Here it is. These are the methods you need to know. So stream, which starts the stream, sorted, map, filter, limit, distinct, and for each count and toList, which is just .toList takes whatever is in the stream and returns a list of that thing with whatever's left over. And so uh, there is there's that. Will prior knowledge of polymorphism be directly tested? It is here. You can assume that it is fair game for the exam. I won't say what specifically is on the exam, but it's on the study guide. You can assume that it is fair game. Okay, here we go. Purpose of Gradle and dependency management. Let me get IntelliJ up. Let's see. Hmm. Sorry, I'm just taking a second to find the particular example that I want. Does this have the one I want? No, it doesn't. What is that? Hang on, I'm trying to remember what a particular example is called. Hang on, I'm pulling it up in my browser here. I can't remember. Well, here it is. Factoring. Where is this? Oh, okay, that was weird. Okay. So, talking about what before each does. So this question is, what does before each do? Let me go ahead and zoom in. The idea is when I am testing, I'm often going to find that I'm setting up the same objects over and over and over in each test. And so rather than set up every single object for every single test, I can define my objects as instance variables, and then from there I use this before each and I initialize the objects here. And what advantage that gives is that oh, starting soon is still on screen. Good point. Not a good streamer. Okay. What advantage this gives is that it just allows me to keep my tests shorter. So if you go back to the example, here was how my tests for library started. This was the duplicate code and clean test in refactoring. Here is how my two tests start. You'll notice that it's very repetitive. Here I'm initializing a hash map, an array list, and a library. Hash map, array list, and library. I'm also initializing a book. I'm initializing a book. The only difference in this setup is specifically this test book copies dot put. I don't have that here, and that's the difference between the two tests. And so by using that before each, what it means is, both, and this is going to sound redundant, but what it means is before each test, so before each test, I run this code. And this means that these values, even though they are instance variables, they get reinitialized every single time because I say before each. So, JUnit does not run the tests in a particular order, but if we can just pretend it does for a second, it would run. So the first test, it would run before each, and then it would run this test, and then it would run before each, and then it would run the next test, and then it would run before each, and then it would run the next test, and that just ensures that each testing state starts the same, and then all I do is, like, the difference between these two tests. is in this test, I have no copies of Gardens of the Moon already in my library. In this test, I do. So that's the one difference in the line. Ergo, my expected outcome is different. Same with, some of these exception cases. So here I have 2 copies. I enroll a patron. I have them check out a copy. Now I only have 1. And the patron has checked out Gardens of the Moon. But again, like the patron list for the library is instantiated up here. And all I'm doing with this given method is I'm saying, hey, add this patron to that library. But the main point of before each is just to allow me to sort of group all my initializations together in one place. It makes each test shorter and more readable. And also it just makes my code more dry, which is always a good thing. Dry, don't repeat yourself. Okay, what is, or could you explain the purpose of Gradle and dependency management? Yes. So, going over to that poi example I have, the point of this dependency management is that I do not want to write code to parse Excel files. I don't want to do it. It sounds really complicated, and I don't want to learn. So, rather than me writing my own library that parses Excel files, I want to use someone else's, like Apache Poi. And so, by the way, if I'm looking over here, it's just understand, like, hey, that's where the monitor is that my code is on. So if that looks weird, sorry. So the gist of this is I say, okay, well, I'm just going to import, and this is a library for parsing JSON. It's one of the other libraries that I use. I have a part of this program that parses JSON files, which is something, by the way, that we will do later on in the term. But the gist of it is I don't want to write the programs that do this, so I'm going to use an existing library. The advantage of Gradle is that I don't have to worry about how I'm going to download or install or set up those libraries. I don't have to worry about making sure that everyone who's co-developing with me also downloads and also installs and has the same version. Instead, the advantage is in this build.gradle file, I just simply say, hey, you know what? Gradle, when I say build, make sure that I have these dependencies, and if I don't have them, download them. And this is one of the big advantages of Gradle W, is that with Gradle W, the way it works is we just clone your code, and so even if you used a library that wasn't Poi for parsing Excel files, we can still make that work, provided that you actually followed the directions in terms of putting things into your build.gradle. So all we do, I mean, I'll show you what we do when we grade your homework, is copy the Git repository. One sec, I need to pull up a folder here. Like, this is how we start grading the homework. Is I'm just going to open a terminal in this empty thing. And I'm just going to do a Git clone. And this is, I mean, the next thing we do is this. Oh, wow, actually, sorry. The next thing we do is we actually CD into the repository. That's the next thing we do. We don't build yet. We have to clone and then change directory into, and then /Gradle W build. And so any libraries that you use, even if it's not Poi, I think there's one called like JXL API, which I actually I used in a study at one point. and I used it instead of poi just because it was smaller, and so there was a program comprehension study. I didn't want to deal with hundreds of classes. Um, but that's it, because at this point now, if you had any libraries or dependencies, it's installed them for this project. So that's the advantage, is Gradle lets me automate that process. Could I go through other examples of parallel streams and when workarounds are available for specific orders? So the only one that's really relevant is the for each order that I talked about in class. And I can show that, like, the consequence of that again. Give me one sec. Um I think this is the same one. I'm trying to make sure that I have my code set up right. Um this is not the same apportionment. Hang on. I'm just going to pull up the functional program example. Okay. So the difference between stream and parallel stream is that parallel stream has uh, basically multi-threading built into it automatically. And so if you have a multi-core processor, which most likely you do, it can take advantage of that by being able to run multiple threads of execution at the same time, right? That's your concurrency stuff in 2100s. That's hopefully nothing too new of an idea. But obviously, I'm not going to be asking about, like, you're not going to be making a thread on the exam or anything, because that's just not something we've done in this class yet. Technically, when we get into GUIs, there's threads, but we don't really have to directly handle that ourselves, as we'll see. So I can change any stream to a parallel stream, but the problem is, especially if I'm reliant upon sorting, is that for each also gets multi-threaded, and that means, like, if I were just to say, let me shorten this for a second just to demonstrate the point. I'm going to remove the filter, so this is just going to sort all the students, and I'm going to sort them by just their ID. So it should be John Smith first. I have two students with 5, 6, 7, 8. Let me change that. So it should be Brian Jones, Tina Williams, Megan Jones, and Jane Doe. I'm currently sorting by ID. Although actually it needs to be comparing in, since ID is an int. Okay. Let me go ahead and run this code. And what you'll see is when it's a parallel stream, the printing may actually end up out of order. For example, Megan Jones is not the lowest, John Smith is. John Smith ended up all the way at the end. And the reason is that the for each assigns everything to a thread, because the goal of a parallel stream is to use threads to complete things as fast as possible. Now, that means you can't use for each. I could use for each ordered, but then obviously I'm going to lose the efficiency of the multi-threading, because if I'm doing things in order, that means it's basically only doing one thing at a time. The As far as any others, I wouldn't worry about it. The big thing I want to take away is that you actually really only benefit from multi-threading when you're dealing with really, really big streams. I mean, tens of thousands of data points, or you're doing very complicated calculations. In this case, I'm unquestionably certain that using parallel streams actually slows it down, because I only have 5 data points. And so from there, the difference between stream and parallel stream doesn't use any multi-threading, parallel stream does. As far as are there any other operations that, like for each, where there's a for each ordered? I'm not familiar with them. Um, the one, yeah, I'm not really familiar with them because, like, there's no reason to worry about order when you're using filter or map, for example. There's just no reason to care about order at that point. Unless you're doing something really weird that you probably shouldn't be doing that's reliant on side effects. And if you're doing that, you should be using for each or peak anyway. Um, but yeah, I'm not familiar with any other operations other than for each ordered for parallel stream. But again, like if you're doing anything the scale that we've done so far, don't worry about parallel streams. It's not really necessary with the scale that we've been dealing with. But have it in your back pocket in case you're dealing with Java later with really big data sets. While we're on this topic, okay, I've gone over that difference. Can you explain the intermediate operations? I can go over them broadly. I direct you to the course pack for details as well as the in-class examples. But I will briefly summarize the 5 intermediate operations that are considered fair game for the exam. So this is under refactoring, under Java streams. Um, there's sorted, takes in a comparator, comparator defined as a lambda body, for example, and it sorts based upon the result of that comparator. Straightforward. Filter takes in a predicate. A predicate is takes in some value and returns a boolean. And if that boolean is true, the item stays in the stream, and if it's false, it's kicked out of the stream. So it's a way to remove elements from the stream that don't meet some criteria. Uh, Limit takes in a number, and it basically, in the case of limit 10, it says only take the first 10 things. If you're using limit, you pretty much should always be using limit after you've done a sorted, because otherwise the order is not predictable, especially if you're using parallel streams. But if you've just sorted, the limit will only take the first 10 things. So generally, limit should only be used after like sorted. Map, take in one thing, return something else. So an example I have here with map is this takes in a UVA student and it returns their first name plus a white space plus their last name. That's just so therefore this goes from being a stream of students to now being, as you can see here, a stream of strings. Um, and then distinct, remove unique elements. There is peak, you don't need to know it, but if you want to know, peak is basically an intermediate version of for each. So for each is a terminal operation. It means that you don't have a stream anymore after for each. And for each actually returns a void, so you can't do anything for each dot anything. But peak is sort of a way to kind of do a for each intermediately if you want to. Um, there's also something like flat map, which what it does is it lets you take like something like a list of lists and flatten it to just a list. But again, not on the exam because it's not something that's like super common. The 5 I mentioned, especially map, filter, and sorted, those tend to be super common. Map and filter tend to be very common, and sorted tend to be common. Limit less so, distinct less so, but I have used them. Okay, I've knocked that one out. Okay, you to the person who asked 4 different questions in the same post. 1 post per question. That's I'm only gonna answer the first one. Um, you know, that's just please try to be respectful of the fact that everyone else is asking questions, and if you put them all in the same thing, it kind of rubs me the wrong way a bit. Okay, can you go over safe and unsafe casting and how that relates to polymorphism inheritance? Yes, I can. let me get my IntelliJ back up and go to do I have this one in here? I may not have this one downloaded here. Let me make a new project real quick. And then I need to get my my notes. Sec to do that. At 0922. Okay, so I have clock and I have alarm clock, and alarm clock extends clock. First, just right out of the gate, worth noting that if I make two clock objects, so clock C, oh, I'm not in the same package. Clock equals new clock, and that's going to be @co. Okay, will work. Oh, no, because I typed it wrong. There we go. And then block or do alarm. And I'll for the sake of demonstrating this, I'll do alarm clock equals new alarm clock, something like that. Okay, so I have two clocks. This one needs to take in a time for the alarm. Let's set it to 5:30. Okay, that's 5:30 p.m. Military time conversion, 24-hour time conversion. Anyway, right out of the gate, I can show you what each type is an instance of. Something like system.out.println, and I can tell you that clock is an instance of object. It is also an instance of clock, which is not surprising. One would expect. And then it is also not an instance of alarm clock, because it's just a clock, and an alarm clock extends clock, but in the same way that yes, every square is a rectangle, but no, not every rectangle is a square, we have the same relationship. If I print this same thing out for alarm clock, one sec to just type all of this. Hard to see my mouse with the mic thing in the way, which is why I'm doing this on the keyboard. So what you'll see is true, true, false, true, true, true. They're both objects. They're both clocks. Only the alarm clock is an alarm clock. So even though I set the variable to clock, because it's initialized as an alarm clock, it really is an alarm clock. It's just wearing a clock costume and getting close kind of remotely. We're like a month away from Halloween, so month and a week. It's a bit, but the point is, at runtime, this object is initiated as an alarm clock, which means I can very safely do something like alarm clock c equals, and this is a typecast. And I'm allowed to do this, and then system.out.println ac. But one thing is, this is kind of unsafe, And what I mean by this is kind of unsafe is that I can compile, this will compile um alarm clock C equals, and I'm going to typecast clock to alarm clock, and this will compile. Notice no compiler errors, and then system.out.println C, and I will get a crash. And I will get a crash due to what is called a class cast exception. This means that I tried to cast uh, a class to another class in a way that's not allowed. So what I can try to cast any clock, anything that extends clock, I can try to cast it to alarm clock. It's just, well, I can try to cast clock, and I can try to cast object. So anything alarm clock or higher in the inheritance hierarchy, I can try to cast it, and it will compile. But this is unsafe because it can throw an exception, as you're seeing here. Where this tends to come up is with the equals method. So if you look, like if I were to have an equals method for this clock, public boolean equals, it's not on, because equals has to take in object O. That's just the Java object class equals method takes in an object, not the class that it is of. I have to do a typecast, and the easiest way sort of do this is just to do an if instance of if O instance of clock, and then this is where I'm going to check equality. And if that's not true, then it's not a clock. I'm just going to return false. That's a pretty common technique you would see. I think in Java you can also do something like try, and I think if you do, well, I mean, you can do a try and then just catch class cast exception and do a try catch. There is a new syntax, but I can't remember if I have it in my. There's a sort of shorthand syntax now. I don't think I listed it. Maybe I did. Okay, no, I don't. I guess I didn't. All right, but that's a class cast exception. If you want to make it safe, you can just use if instance of, or you can do a try and then catch class cast exception and handle that. That's how to make that type of thing safe. If you don't know, for example, if the class, like say you have a list of clocks and you don't know which ones are alarm clocks, that's a way to sort of filter that out. All right, let me get back to the questions. Here's one. Does Git add stage changes in all branches, or does it do it for only one branch? It only does it for one branch. So you only are ever interacting with the repository in the branch that is currently active. So you have an active branch that you're working in, and when you do an add, it only stages the changes. Because remember, add doesn't just add files, it says stage changes. It only does it in the branch that you're working in. And that's an intentional design decision. The idea being that within your branches, you should just basically be working only within a branch at a time. Any changes you make, you only want to reflect in one branch at a time. That's why we separate branches and then have a merge command, because the merge is saying like reconnect these branches. Is there a way? So this is the follow up. Is there a way to git pull in all branches at one time? Not from command line trivially. There are some GUIs that will do it for you. I'm not familiar with any command to do a git pull on all branches at all times, but typically within, let me see if I can um to look at testing intro. I think it might be here. Do I have multiple branches here? I'm not entirely sure if I do or not. Yeah, I do. You can still pull from the GUI in this way, but really recommended to just, hey, if you're switching to a branch, the first thing you do is you pull. You know, switch to the branch, pull. Just kind of get into that habit. There, to the best of my knowledge, there's not a way to pull from them all at one time. Okay. Yeah, so the point of the Gradle wrapper, that this is why we use Gradle W build, is even if you haven't installed Gradle on your computer, you'll notice in our project, inside of this Gradle, there's this Gradle wrapper.jar, which is of course a Java jar. By the way, this is why you get the message often that says, "Oh no, it's not compatible." It is. First, Java 18 didn't introduce any new features. It's more a warning because, hey, maybe something changed and it might not work. But again, if it works, it works. That's the bare bones idea. But the other thing you can do if you want to update your Gradle version to one that does work is in this Gradle wrapper properties, just change this to, I believe it's the current version is 7.5.1, I believe. And then at that point, if you want, you just do a Gradle build. And this is nice because notice you can see right now here I have Gradle 7.4 installed. Watch what happens. Oh, build fail. Oh yeah, because I failing tests. But notice if I refresh, you'll notice that, oh, that's Gradle 7.5.1 now. Updated. Hey. And that's because the point of the Gradle wrapper is that it installs Gradle for you. So it removes even the need to have Gradle installed. The only thing you need is a working version of Java that's up to date, which again, you should be using a most recent version anyway. But again, that's just this last little bit is the version number here in the Gradle wrapper properties. You can update that way. There's probably a way to change the default in IntelliJ, but I have been looking for it and have not been able to find it. So it's probably buried in some setting somewhere, but yeah. Okay. I have hit the end of the questions that are relevant to the exam. So, unless there are more questions, I'm done. I will upload this to YouTube. I have the review, which actually went 2 hours, although admittedly I got off topic quite a bit. From Friday night is already in Colab, but you know, if you have questions, feel free to ask them. I'll hang around for a couple minutes, but after that, you know, I mean, I don't have a shortage of things to do, so I can certainly work on other stuff. Even, I mean, it's for this class for clarity, and you know, hang on. This is Colby Bear. He's a kitty cat. He's very floofy. He's a very sweet boy, but he's very, very floofy. Stuart is over on the chair. Let me see if I can... He's over on that chair in front of my bookcase. That's Stuart. Those are my two boys. They tend to live down here with me. I don't live in the basement, but all right. Well, hang on. I got a 9th somewhere in there. Be able to tracing code. So let me explain what tracing code means. Tracing code is I present some code to you, and like an example, albeit this is not a great one. I'm just pulling it out thin air. But an example of tracing code would be something like, you know, I give you, here's the current state of this object, and here's this function called with like 5. And you tell me what the state of the object is after, or you tell me what prints or something. Tracing code just means basically executing by just reading, not really running the code, but executing the code like mentally as you step through it. And the common debugging thing that you would do. It's a debugging strategy. So that's what I mean by tracing code. Tracing code with inheritance just means, hey, you can do that when polymorphism's involved, when inheritance is involved. So something like with where did it go? Here it is. Something like you'd be able to say like with clock, or with alarm clock, if I called update, then with update, notice it says super.update. That tells me I need to go to the parent class and trace this code, and then I come back and run check alarm, which means I come down here and yeah. Or down here where it says get current minute, you'll notice the field's not here, but that's because remember it's extending clock, and so it inherits the parent's protected and public fields, not the parent's private fields, but the parent's protected and public or protected and public fields it inherits. Okay, all right. Let's see. I'll give another couple minutes for anything to get posted, but otherwise, gonna get back to working on the writing for this week. By the way, the music I was playing was from a game called The Last Spell, which is just has some wonderful, wonderful music to it. Yeah, it's just great. It's a really, really fun like strategy game. It's kind of like I don't know, it's hard to describe the game. For those who are gamers, best way I can describe it is it's like Final Fantasy Tactics meets Dynasty Warriors with a little bit of They Are Billions thrown in. Um, was there any branch conditional path coverage metrics? That is. So and I'm only I can answer it, but it's just easier for me to like, hey, look, it's in the slide. So if you forget, you can review it. It's right here. And the statement coverage is the percentage of lines of code that are covered in like, so maybe this is a function and you're seeing what percentage of lines of code in the function are executed, or maybe it's a class level, whatever it is. You have some block of code. You have tests. Tests execute that code. Do they execute every single line of that code? If yes, it's 100%. If no, however many lines are executed divided by the total number, that's your statement coverage. Conditional and branch are a bit trickier. Conditional is for every Boolean expression or combination Boolean expression, so like things with and or, you have tested every combination possible of true and false. So like if you have a Boolean with an and, testing true, 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 false, false, true, false, false. And sometimes that's not always possible. For example, if I said something like x is greater than 1 and x is less than 10, it's impossible for both of those statements to be false. So at that point, you have to take that into account. Branch coverage is similar, but it relates specifically to conditionals and loops. Specifically that, and this relates, you might think like, well, with if statements, it's the same as statement coverage. But an if statement doesn't have to have an else statement, right? And so it's possible, for example, that you get 100% statement coverage by executing the if, but since it has no else, you never check when that if condition's false. So that would be covered by both conditional and by branch coverage. With loops, with branch coverage, we think of it typically as no pass. You want at least one no pass test when possible. Like if you're doing something like looping from I is 1 to 10, obviously you can't do a 0 pass. But you want to test 1 0 pass and 1 multi-pass, sometimes a one pass, depending on the function. If it's a do while, you're certainly going to want to test one pass. Path coverage is within a given piece of code, basically all the ways that you could path through that code. So, like if you have an if else and then an if else, and the two conditions are independent, you'd want one test that does the if, one that does the if else, one that does the else, and one that does the else and then the if. Basically, every combination patterns. That can be very tricky, especially if you have really long methods. The nice thing about these metrics, though, is that if you're actually doing like honest to goodness test driven development and you're making sure that your methods are small, it's actually pretty easy to do. It's actually pretty easy to do full coverage because your methods are so small. The more complex your method gets, though, the harder it gets. And again, that's per method based test, not. And this is not getting into things like if you have one method that has like 10 private helper methods, then it gets more complicated, yada yada yada. Okay. You have an assertion error and when to use them. The short version is don't. So assertion errors are a development tool. They are not a deployment tool. So it's fine to use them while developing, but you shouldn't have them be in production code. So the idea of an assertion error is there's a statement which is for halting, and it's assert, and it's some Boolean expression, not literally assert true or assert false, but is some Boolean expression, and if Boolean is false, it raises an assert error or assertion error. Now, to be clear, by default, Java ignores assertion errors. It doesn't. It's just like, okay, cool, assertion error. Anyway, moving on. It's like the Top Gear meme, like, oh no. Anyway, and they just kind of keep going, right? Um, but the gist of the assertion error is that you generally use it for development as a way of enforcing preconditions, and it's useful because when you first start building the software, you have these agreed upon contracts between the classes how they're going to behave, but until you sort of reach a critical mass of code, it may be not like it may be easy for someone to make that mistake, to use an interface incorrectly, whatever, because you don't have the critical mass of code in place to sort of prevent it. Um, but like lower level classes, generally you shouldn't need to be doing things like checking for null because nobody should be passing null if it's a lower level class. Now it's different if you're making like an API library. What I mean by that is some of the classes are classes that human, like other programmers, are going to interact with. Like so in Poi, there's workbook and sheet and row and cell, and humans are going to use those, and so you need to have defensive programming in place there. But you don't need error checking necessarily at every level of the program, and so assertion errors are like a good while you're developing tool, but presumably they should basically be unnecessary by the time they get to production. But again, like by default, they're not enabled. You have to enable them with EA. The one time that you do end up seeing them that you all have is when you're JUnit testing. But when you're unit testing, you're running with that assertion error turned on, and that's because that the assert method is basically how the JUnit assert methods work, kind of. So that's the gist of that, and what's the difference between an interface and an abstract class? There's two ways to answer that question, and the first is when can you use an abstract class that you can't use an interface? If you want to have some code existing in an abstract class because every child inherits it, I'll give you an example. In my state readers, uh, in no matter what kind of state reader I have, I'm going to make a list of states. So I'm going to have a list. I'm going to add elements to it. So if you look at the state reader code I gave for the homework, there's in the abstract class state reader, it has the list, it has that memoization thing I talked about, which is, by the way, memoization, notice not on the study guide, not on the exam, it's just mentioning that that's what that code is doing. You'll notice that it then they or CSV state reader, Excel state reader, they just interact with that array list. They just add directly to that array list, that protected array list. An interface can't do that. In general, more broadly, they can be interchangeable, especially if your abstract class doesn't have any working code. They can be interchangeable. There are some structural differences. So I will go ahead and pull that slide up now. Some of the limitations are, for example, with an interface, you can implement multiple interfaces. You cannot extend multiple classes. And you can't implement an abstract class. You have to extend an abstract class. So you can only extend one class. You can implement as many interfaces as you wish. This is useful for when you want the interface to basically describe a feature that's being added to a class, like comparable. That's a good example. But there's not like a super consistent like case where we only use inheritance when we're saying it is a relationship, because that's not true. Like array list implements the interface list, and so list is an interface, not an abstract class. So it's not like super consistent how Java handles it internally. Generally, whenever I'm defining an abstract behavior, I use an abstract class. Uh, Generally, that's my starting point. Not always. Sometimes I use an interface. It kind of depends. But in general, it's not any case where you can use an interface. It's not wrong to use an interface. It's just only when you need some existing like shared resources between child classes, whether those are fields or functions, then you need an abstract class. Um, well, I should say fields. Uh, Functions, obviously, interface can do, but you want actually function implementations. Interfaces can't have implementations, save for the default keyword, but that gets into a weird place when we start talking about the default keyword, and I've sort of intentionally avoided bringing it up. This is the difference. There you go. All right. I think I'm going to call it there. Thank you all for coming. Best of luck on the exam, and I will see you all next time. Well, I'll see most of you on Tuesday, and others of you obviously will see Professor Wynn.